Chapter 23, Energy and Mineral Resources. Renewable and non-renewable resources. Resources can be divided into renewable and non-renewable resources. Renewable resources can be replenished over relatively short time spans. They include plants and animals for food, trees for lumber and paper, energy from the sun and wind. Non-renewable resources are deposits that take millions of years to form. Examples include fossil fuels and metals. Annual per capita consumption of resources in the United States. Well, we use lots of non-metallic resources. We use lots of stone, sand and gravel, cement, salt, clays, phosphate. Our metal resources, well, we use mostly iron, and we also use some aluminum, copper, lead, zinc. Petroleum, we use a lot of petroleum and coal and natural gas. Coal, petroleum, and natural gas are the primary fossil fuels in society. Fossil fuels use energy from the sun stored by plants and animals millions of years ago. Reserves are declining and future energy needs will be met with alternative energy sources. Okay, so U.S. energy consumption in 2011. And so petroleum, about 36% of all the energy used is petroleum-based. And the consumers of that, let's say, are transportation, and industry, and residential commercial, and some for electrical power. Natural gas, 20.5%, is also consumed by transportation and industry, residential, and electric. And coal, 20%, consumed more by industrial, residential, and electric. And renewable, transportation, industrial, and residential, and also some for electrical power generation. And nuclear power is mostly just for electric power generation. Coal today accounts for 20% of the nation's energy needs. The major fuel used in power plants to generate electricity. Causes of coal use include environmental damage from mining and air pollution. There's a coal field in the United States. Oil and natural gas combined provide more than 60% of energy consumed in the United States. In 2011, natural gas exceeded coal production for the first time in 30 years. Petroleum formation, both oil and natural gas, consist of hydrocarbon compounds that are found in similar environments. Formation begins with the burial of large quantities of organic material from plant and animal remains. Organic materials transform into liquid and gaseous hydrocarbons through chemical reactions with increasing burial over millions of years. Liquids and gases migrate into permeable beds such as sandstone. Traps for oil and gas. An oil trap is an environment that allows for economically significant amounts of oil and gas to accumulate underground. All traps have two basic conditions: a reservoir rock, which is a porous, permeable unit, not like an aquifer, and a cap rock, impermeable unit. Common traps are anticlines or fault traps, salt domes, and a stratigraphic trap. So here's our examples. So in an anticline, we might have an impervious layer here. It's our cap rock. And under here we have our reservoir rock. So we might have water, and above it we have oil, and then we might have gas. A fault trap, say with this fault, one side, the fault slid down, one side slid up. So this cap rock forms a seal that traps the water, the oil, and the gas. Now salt dome may also help trap oil and water and gas. And then stratigraphic or pinch-out trap, we have a reservoir layer that pinches out, surrounded by the impervious cap rock. Hydraulic fracturing. In some regions, significant amounts of natural gas are trapped in shale with low permeability. This shale is shattered by fracking to release gas. Concerns for groundwater contamination and induced seismicity is still a controversial practice. Oil sands, mixtures of clay and sand combined with water and bitumen, a viscous tar. Oil in oil sands is much more viscous and cannot be pumped out. Several substantial deposits around the world, largest reservoirs in Alberta, Canada. Obtaining oil from tar sands requires large amounts of energy and significant environmental drawbacks. Here's some oil sands in Alberta. Oil shale contains enormous amounts of untapped oil. Currently, because of the world's markets and with current technologies, it's not worth mining. Here's the Green River Formation, okay, of oil shales. Gas hydrates, a fuel from the ocean floor sediments. Gas hydrates are an unusual compact chemical structure made of water and natural gas. Methane hydrates are the most common. Resembles ice, but ignites when lit by flame. Here's some gas hydrates. Looks like ice, and here it is lit by flame. Nuclear energy is an important part of U.S. energy needs. Fuel comes from energy released by nuclear fission, the splitting of atoms. Resulting controlled chain reactions releases heat used to drive steam turbines. Uranium-235 is the only naturally occurring isotope that is readily fissionable. Primary fuel used in nuclear power plants. It's a rare element air suppressed. Obstacles to development. Well, plant safety. For example, Fukushima nuclear power plant, 2011. It was the earthquake or the tsunami that destroyed that power plant and led to massive contamination. So it was the tsunami just destroyed the nuclear power plant. Renewable energy sources regenerate and can be sustained indefinitely. The use of renewable energy is not new. 150 years ago, wood supplied most of our energy needs. 13% of U.S. electricity is generated from renewable resources. Okay, so renewable energy. So we have petroleum, coal, natural gas, nuclear, electric, and then renewable is about 9% of what we use, and that new renewable is divided up between 35% hydropower, 22% wood, 21% biofuels, 5% biomass waste, 13% wind, 2.5% geothermal, and almost 2% solar. And these are charts of how we've been using more and more renewables since 1973. It's kind of skyrocketed in the past 6 years. More hydropower is here. Biomass is doing more than hydropower. Solar, wind, and geothermal is on the increase. Solar energy. Direct use of sun's rays to supply energy. Passive solar collectors are south-facing windows. Active solar collectors are photovoltaic solar cells that convert sun's energy directly to electricity. Stirling dish converts thermal energy to electricity. So here's some photovoltaic cells. Photovoltaic solar resource potential in the United States, where it's where it's greater than the purple, the blue is the less. So the red, orange, and yellow is where the most potential for photovoltaic cells for solar energy. Wind energy, converting kinetic energy of moving air, mass, wind, into other forms of energy to perform work. Increasing the number of wind turbines installed. Wind speed is crucial in determining suitability of installing a wind energy facility. Okay, and the red is areas of excellent wind potential, good is orange, and yellow is moderate. Hydroelectric power is power generated by falling water used to drive turbines to produce electricity. Most energy is produced at large dams. Dams have finite lifetimes. There are limited sites to construct dams. Here is the Grand Coulee Dam. Geothermal energy is power generated by steam and hot water used for heating to generate electricity. 3 factors determine geothermal reservoirs' commercial value: to be a potent source of heat, large and porous reservoirs, and a cap of low permeability rocks. In Iceland, there's a lot of geothermal development. So in this peak band, there's a lot of resources. This is a geothermal power station. Biomass, renewable energy from plants and animals. Biomass is organic material made from plants and animals, includes wood, crops, manure, and garbage. Tidal power, ocean's energy potential remains largely untapped. Tidal power is harnessed by constructing the dam across the mouth of a bay or estuary in coastal area. Turbines are mounted just offshore too to tap tidal power. Okay, so here's an example of with a dam, power generated, there's impounded water, and it goes like hydroelectric. It's low tide. High tide, that bay gets refilled in. So when low tide again, we generate more power. Mineral resources are the endowment of useful minerals ultimately available commercially. Mineral resources include reserves, already identified deposits from which minerals can be extracted profitably. And ore is a useful metallic mineral that can be mined for profit. Known deposits that are not economically or technologically recoverable. Excuse me. 98% of continental crust is composed of only 8 elements. A deposit is valuable if the element is concentrated above the level of its average crustal abundance. Profitability of the deposit may change as demand changes. Most abundant minerals in continental crust, mostly oxygen and silicon, but we have iron, potassium, magnesium, sodium, calcium, aluminum are other majors. Magmatic segregation separate heavy metals that crystallize early or enrichment of rare elements in residual melt. Sometimes crystals form a fluid-rich environment. As fluids don't solidify, the crystals grow unusually large. So pegmatites or rocks are unusually large crystals. So here we have some humongous pegmatites, big crystals. Diamonds, best known as gems, are commercially used as abrasives, originate great depths. Crystals are disseminated in ultramafic rock called kimberlite. Hydrothermal solutions. Hydrothermal hot water solutions are best known and most important ore deposits. Vein deposits, hot metal-rich fluids migrate through the cracks in rock before eventually depositing the metals. Hydrothermal metamorphism can occur at shallow crustal depths in regions where geysers and hot springs are active. And here we have all these hydrothermal vein deposits. Hydrothermal solutions disseminate deposits. Instead of being concentrated in narrow veins, disseminated deposits are distributed as small masses throughout an entire rock. Example, copper. Hydrothermal activity at ocean ridges. Black smokers are a source of metal-rich sulfide deposits. Metamorphic processes. Many important ores are created by contact metamorphism. The most common minerals associated with contact metamorphism are sphalerite, galena, chalcopyrite, magnetite, and bornite. Weathering creates deposits by concentrating metals into economically valuable concentrations. Secondary enrichment. Bauxite, principal ore of aluminum, forms in rainy tropical climates from chemical weathering and removal of undesirable elements by bleaching. Here is some bauxite. Other deposits. Weathering processes concentrate metals are deposited through low-grade primary ore. Examples are copper and silver. It typically occurs in deposits containing pyrite. Placer deposits are formed when heavy metals are mechanically concentrated by currents, developing heavy and durable minerals. Examples include gold, diamond, and tin. There's some placers. This guy is panning for gold, and the ship's probably panning for gold in a different way. Use of the word mineral is often broad. Minerals not used for fuels or processed for metals are called non-metallic mineral resources. There are two common groups, building materials and industrial materials. Building materials are natural aggregate, crushed stone, sand, and gravel. Gypsum for plaster and wallboard. Clay for tile, brick, and cement. Aggregate is a building material, help build our cities. Industrial minerals, fertilizers, nitrate, phosphate, and potassium compounds are important to agriculture. Sulfur is used to produce sulfuric acid, and salt is used to soften water, keeps streets ice-free as a nutrient. That's the end of that chapter.